All right, welcome to section 4.2 of our AP Calculus class. We're going to be talking about implicitly defined functions. And an implicitly defined function, as you may see from the definition, is a function where it is implied that y is equal to a function of x. So an explicitly defined function, y equals 2x, says, I take the x value, I multiply it by 2, I get y. But what about the following function? X squared equals y plus, 2y plus 5. Well, it looks to me like y is a function of x. In fact, if I were to go ahead and solve this, I'll subtract 5 and divide everything by 2. I get y equals 1/2 x squared minus 5 halves, and check, y is a function of x. But this is implicit. We are looking at that and we are saying, oh, y is some function of x. Now, if I want to find y prime, in this case, super easy. I've written it as an explicit function, and all I have to do is take the derivative of the explicit function and use the power rule and the constant rule, and I get the derivative of that is x. It is a straight line. So what about this? X cubed plus y cubed minus 9xy equals 0. Well, y is a function of x. The problem is I don't know what function of x, and I don't have any way to find it. I have no way to solve a cubic that has x's as its various bits. So I'm sort of stuck there. So this is where implicit differentiation using the chain rule is going to come in. And we're going to start with a really simple example. And our really simple example, ignore that, is y squared equals x. Implicitly, I know that y is a function of x, and I could very easily just take the square root of both sides, but I'm not going to. Here's what I am instead going to do. I am going to take the derivative with respect to x of y squared, and I know that must be equal to the derivative with respect to x of x. So, what is the derivative with respect to x of y squared? Well, what I've got here is I've got an inner function and I got an outer function. And y is my inner function, a function of x. So the chain rule now says that I can take the derivative of the outer 2y times the derivative of the inner equals, well, the derivative of x is 1. Chain rule, derivative of outer times derivative of inner. Now, notice that normally what I would do is I would then say, oh, I've got to go back and I've got to rewrite y as a function of x, but I don't know y as a function of x. Well, in this case, I do. Going a little bit further, however, with this problem, what we then see is that the derivative of y is equal to 1 over 2y. Y, the derivative of y is a function of y. And that's okay, because when we're looking at these implicit derivatives, these implicit differentiation, often the equation comes from a result of a problem. And what we're discovering here is that the slope of this function depends on the y value. And we'll talk more about this as we go on. So if you are in my class, why don't you go ahead and do exercise 3 in the book. And when you come back, we'll look at this graphically very quickly and then stop this video. Okay, so you had an opportunity, hopefully, to stop and do exercise 3. You've checked your answer. Let's look at the function y squared equals x. This is a sleeping parabola. And let's say I want the derivative at x equals 4. So here's x equals 4. I know that something squared is 4, so there are 2 points on this graph. Y could be equal to 2 or negative 2. I know that the derivative is 1 over 2y. So let's see what we get. Well, slope equals 1/4. Slope equals negative 1/4. And that actually makes sense. That the slope of this function doesn't depend on where I am in the x value, because that gives me 2 possibilities. It depends on where I am in the y value. If I am up here, then I've got a positive slope of the tangent line, and if I'm down here, I've got a negative slope of the tangent. All right, so we will come back with some more examples and some more complicated examples on the next video. Thanks for watching.